So we look at distance along the great circle. Distance along the great circle. Sometimes this is also called as distance along the longitudes and the equator. As we earlier on said, the longitudes and the equator are great circles. So any calculation of the distance, we have the same formula. Now, let's take a look at what formula are we going to use to calculate the distance along a great circle. So the formula, the distance d along a great circle will be equal to the angular difference all over 360 degrees times 2 times pi and capital R. So this is the formula we are going to use to find a solution to the distance between two places on the earth's surface along a great circle. Let's take the first example dealing with the distance along the equator. 1. Distance along the equator. Let's assume that there's a location A on the equator, and of course we know that the equator is latitude 0 degrees, and then let's assume we have the longitude here as 75 degrees east. And then there's still another place on the equator, and it's also defined by latitude 0 degrees, and this time around, let's say we have the longitude of 45 degrees, let's say it is west. Now, we are required to find the distance AB. Find distance AB. We may wish to represent the A formation diagrammatically. So let's draw a diagram in our solution. Let's represent this. And then we have here, and then this is our equator. This is the North Pole. This is the South Pole. This is the center of the Earth. And this is your latitude 0 degrees, the equator. So this is the equator. Alright? And then we have 75 degrees east, which runs like this. And then we have 45 degrees west, which also runs in this form. So this is your position here, and this the position here. The first one is your A, the second one is your B. And we are looking for the distance between A and B, and that is arc AB. Now, if we bring this out by what we have, let's bring it out. So we have this diagram here. We have this, you can bring it out in a simple form. This is your point B, this is your A, this is O, then this angle is our alpha. And of course, this is the capital letter R, the radius of the Earth. We have to find from A to B. First and foremost, we will find our alpha, which is the angular difference. The angular difference here, 75 degrees to the east and 45 degrees to the west. So we add them together, that will give us 120 degrees. Beautiful. Now with this done, we can therefore write the distance AB is equal to the angular difference over 360 multiplied by 2 per and capital letter R. Usually, sometimes these 2 per R is given to you as 40,000, assuming we are giving that. Or on the other hand, we know the value of R, we know the value of per, so we can use any of them. So our 2 pi R, if we use 40,000 kilometers, then for our AB will be equal to, the angular here is 120 all over 360, multiply this by 40,000 kilometers. And of course, from what you can see there, this is 1 over 3, and 3 will be dividing 0 will cancel 0, 12 here into 36 is 3. 3 dividing this, that will give you 3 into this is 1, into 10 is 3, another 3, another 3, another 3.33 kilometers. And then we may be asked to correct our answer to 3 significant figures. If we are to do that, what then will be the solution? So this will be equal to 1, 3, 3, we have 0, 0 kilometers. This is now corrected to 3 significant figures, as the case is. So this is the distance between A and B along the equator.